sustainability was the prime topic of the presentation. So I would like to ask, how can energy efficiency and sustainable development initiatives can improve the building performance? I would like to start with Mr. Bengali.
Arjuna, thank you very much. It's a very important question, and sustainability is a key. Today, we're talking about not just sustainability, but we are talking about decarbonization as well. In any building operation, energy efficiency is a key measure because that consumes a large amount of power and it's been used for various different applications. Energy efficiency measures can start from a building design itself as to how well you are designing the building. It can start from orientation. It can start from the structure as to how good you are thermally insulating the structure, be it the walls, be it the roofs, how well you're using various different elements of the HVAC system, the lighting solutions, so on and so forth. It is a very important element, and a lot of effort has to be put in for really identifying and selecting the right solutions which can help and give sustainability in a building design.
So design is a very important aspect to mitigate the thermal management practices. So Mr. Azmi, can you tell me, like you mentioned that using European standards does have considerable effect in thermal spaces. So how do you think their model can be applied in tropical and subtropical regions? Like, will it need any design modifications?
Of course, we need to change. For example, if we talk about what I mentioned in terms of European standard and ASHRAE standard, the American standard was the ventilation rate. So when you need to deal with this, one of the most important factors that will come in mind is ventilation. Because when you want to increase the ventilation for indoor spaces in order to take non-adapted people into consideration, and you want to increase the ventilation rates, you need to think about a way, because ventilation rates or ventilation itself, the ventilation system will consume around 25% of the air conditioning cost. And the air conditioning cost is around 50% of the total building cost, energy cost I'm talking. So it means we are dealing with a huge amount of energy to bring this ventilation air into the space. So when we need to do so, we need to think about, as I said, we need to keep the energy cost in mind without sacrificing the indoor environment. So how to do so? If we know that people breathe in any space, we breathe around 1% only of the ventilation air we are supplying in any space. So if you supply that huge amount of ventilation air, you are only breathing, all the occupants are only using 1% of this ventilation, and the remaining 99% is just wasted because they will return to the machine and they will become return air. So we need a way, and here's my answer, we need a way to deliver the ventilation air directly to the occupants to make it more efficient. And there are ways of doing so, like using personalized ventilation. Like, for example, when you have a table lamp, so that you can focus, you have light directly on your table. What to do in terms of ventilation? We need also to put an air outlet, which is on the table. And this is what they call it, personalized ventilation. Or you need to put an air outlet on the ceiling, especially in office spaces, where it is directed to the occupant or around the occupant, in the proximity of the occupant. So the occupant will breathe this ventilation air right away from the air outlet. So this is one way. And of course, in tropical and these regions, we need also to think about the humidity, and we have to deal and dehumidify this ventilation air in advance, because we don't want to deal with the humidity in the space. It will take us lots of efforts. We need to deal with it from the source itself. Before we supply all of this humidity to the space, we need to dehumidify it properly. And for this, again, there are in many buildings, you will find that the dehumidification process or the components which are dealing with dehumidification are the same components dealing with cooling. So people in their design, what they do, the cooling coil is cooling the air and at the same time dehumidifying the air because it is taking the moisture out from the air. And then they think that this way it is appropriate to handle humidity. No, we need to make a dedicated system only to dehumidify the air. Why? In part load calculation and part load hours, when part load is there, the cooling coil is not working at its full efficiency or full capacity. And in these situations, we are allowing, if we don't have a separate system for dehumidification, we are allowing humid air to enter into the building, and this will achieve problems in mold, odor, and so on into the building.
That was very well put together. So since you mentioned about occupants, Mr. Ramnani, I would like to pass it on to you. So how can technology influence the occupant behavior on thermal management so that they can adapt energy efficient habits?
My take is that, the building needs to be considered while designing the air conditioning system on ASHRAE advocated standard 55, which is nothing but adaptive cooling. Now, adaptive cooling is talking about not only the temperature, but it's talking about temperature, humidity, air cleanliness, as well as air movement. And as I was trying to show in my slides as well, adaptive cooling will take into consideration what is the activity level of people inside the space, as well as what is their clothing level. So there's no fixed temperature which will give comfort to everybody. Like if you design this building even at 27 or 28 degrees instead of the conventional 22 degrees, but you take care of other aspects, then majority of the people will be comfortable. This is what ASHRAE also advocates. And already we have seen countries like Japan, countries like China, they have started to raise their set points instead of 22 to 28 in public spaces. All the public spaces by default are maintained at 28 degrees. And then they ask people to adopt by making their changes and taking into consideration what kind of activity level or what kind of clothing they are going to be using there. By doing this, there is a huge amount of energy saving. So definitely, the end user is benefiting by spending less energy. Also, we are helping environment by reducing the carbon footprint. So this is the need of the hour, and I'm sure, more and more people have started taking this into consideration, especially the designers.
Correct.
Yeah.
So since you cited international examples, so how do we implement that? Like, what are the challenges we are facing to implement those things?
Frankly speaking, it's a mindset. Conventionally, the mindset has been the air conditioning means 22 or 23 degrees. This is something which we need to change. Then we also need to bring in more fresh air so that, the comfort level or the freshness factor inside is directly felt by the occupants. As I was giving some examples in the IT buildings where, the software engineers are working day in, day out. Sometimes they are working for 10, 12, 14, 15 hours also. When they need a break, they are not, sent to conditioned buildings. They are sent to the buildings or the spaces which are having a lot of fresh air. They are able to really get refreshed. They are able to charge themselves up and then again go back and, start the complex work of coding and, making the software programs. So this is small changes which we need to adopt into our work culture. And I'm sure there is already a beginning on this front. And I'm sure in times to come, this is going to be catching on. And as we keep demonstrating, these kind of examples and, people start getting convinced, this will become quite, usual practice for any MEP or HVAC designer.
Correct. So the mindset change is paramount. Correct.
Yeah, and by leading by example.
So, Mr. Bengali, I would like to ask you how to address challenges while upgrading traditional HVAC systems to smart systems for dealing in larger spaces.
It's a fabulous question because we come across this on a daily basis. We come across this through various different facades of stakeholders, starting from the end customer to the designer to the installer. To me, what is very important, I agree with what Mr. Vinod spoke last. I think leading from example is an important case. A lot of individuals, stakeholders are looking for proof of concept so that they can rely on those. Others are leaders who would want to believe on certain elements and move forward, and the rest would follow. That's the typical process of what's happened. If you look at it from from an example of the HVAC industry of duct insulation, if you go back to 15, 20 years back, it was predominantly taken care with glass wool insulation. Over the period of time, which is from a price level, the lowest. Even today, from a price level point of view, glass wool is much lower, but the entire market has shifted from a glass wool insulation to a nitrile rubber based insulation, which is expensive, but it is offering value. To me, what's very important is if you are able to substantiate, demonstrate the value of the product, and the value can be in all aspects of it. I mean, for example, a nitrile rubber can save 1 inch of space between the false ceiling and the slab. That itself is a value, because let's say I'm based in Mumbai. Over here, every square millimeter or square inch is very, very essential. So if we are able to articulate the value, that is what has really worked. Now, when I talk about EPDM as an insulation, as I briefed in my talk, if you talk about fire, if you talk about moving beyond fire is about smoke, people have started acknowledging it. Most of the government buildings today which are coming in, they are going ahead with EPDM insulation. We have supplied it for many of the projects across the country where they have understood long-term performance. And once they understand it, they are able to accept it. There is still a big gap between value and how we can justify or substantiate the value in terms of money. Because having said that, the money or the incremental cost will always come as a part and parcel of the consideration. However, once someone understands, and that is the most important part of the end customer, once you understand that, I think they are able to move beyond the level, and we will see the movement happening across, not just in the category of insulation, but every single category. So that's my response to your question.
Thank you. So cost will always be a part of a consumer's outlook. And since you mentioned insulation, so what practices can make insulation techniques more effective for different types of buildings?
As I said, there are different insulation material available, from an open cell to a semi-closed cell to a closed cell insulation available. First, to me, is the selection of the right insulation material plays a very important role in terms of the technology. Second, to me, is how it is installed properly. So if I talk about a pipe insulation, for example, a pipe might have 2 pieces of insulation which is put across, but if there is a gap left, the gap is good enough for condensation to form in future, heat transfer to be formed in future. In the conventional form, if you see it in most of the buildings, any insulation pipe is covered with jacketing. Is it with an aluminum cladding or with GI cladding? Now, if you look at how it is being done, a cladding is eventually grooved, and then you have a self-tapping screw which is punctured in it. The cladding is roughly around 0.6 to 0.8 millimeter. The screw is 15 millimeter, which means it is puncturing the insulation. Now, when you're puncturing the insulation, you are allowing moisture to pass through, which is what we call as thermal bridging. If you were to look at these elements and make sure that the design is done well, there's a very classic saying which says that the devil lies in detailing. And if you were to do that, I'm sure that all technologies would be very well accepted, and it will eventually yield the value which the buyer wants to have.
Thank you, sir, for covering. Insulation is a very important part of HVAC, and thank you for covering it so well for us.
You are right, Darshana, it's a very important part, but incidentally, it happens to be contributing just to 3 and 5% of the HVAC part. It's pretty small, but it's very significant. If you look, there are a number of studies which have been done, which has shown that insulation is the most cost-effective measure to make system energy efficient. There are different measures which one can use in a building, starting from as simple as going for an insulation to as high as maybe going for renewable energies in your building, and so on and so forth. Insulation is the most cost-effective way of doing it, and that's an important element that everyone understands and uses it appropriately.
Thank you. Moving on to Mr. Azmi, can you tell me whether solar panels integration into existing HVAC systems of public utilities can bring down maintenance cost and energy consumption?
Yes, definitely. But I would like to add on the insulation part. What was mentioned is really insightful. And I would like to add one thing also in terms of insulation. We need to apply insulation in a way that goes in line with the operation. And I will give an example. When we insulate walls, for example, we need to think where to put the insulation. Shall we put it inside the wall in the center? Shall we put it towards the inner side of the wall, adjacent to the interior part, or shall we put it on the outer side or exterior side of the wall? So these decisions, we need really to think about it. And what difference will it make? It will make a difference in terms of the thermal mass of the building, of the interior of the building. And you know, the thermal mass, when it is more, then it will take more time to cool it down. And when the thermal mass inside the building is less, it will take less time to cool it down. Okay, what this will affect me? It will affect, for example, if my area is something that I have to go in and out frequently, then I need something that will cool down quickly, because I don't want to wait more when I enter an area to cool the area down, especially if the air conditioning system is off. So when I enter, put the air conditioning on, I need to wait for less time. And here I put the insulation towards the inner side of the wall to reduce the thermal mass. And on the other side, if this area is occupied for the full day, for example, then yes, increase the thermal mass in the building and put it on the outer side, because it will take more time to cool, but it will take also more time to lose the heat and to become hot. So it will help in reducing the peak demand or offsetting the peak demand of the space. So when we think in a deeper way and we relate the implementation of the insulation with the operation, then we can also get into more sustainable solutions and more energy efficient solutions using the same amount of insulation or the same cost. And going back to the solar, yes, solar is very important. And again, I would like also to mention how this can be implemented in a way that, for example, when we implement solar, let's implement it in a way that will have shading effect on buildings, so that we get the shading effect, which will reduce the cooling load as well, and we generate electricity from it. So nowadays, building facade is not only for aesthetical reasons. Nowadays, building facade, we use the facade for media, for advertisement, and for generating energy as well, or reducing the cost of cooling load and so on. So when we think about it in this way, we will get the benefit of this electricity generated while we also reduce the cooling load. One more example I would like also to mention is we need to make sure that this solar panels, which are being designed mainly, the concept is being designed in Western countries where cooling loads, where the outdoor temperature is less. The problem with these solar panels is that they reduce efficiency, or the efficiency is reduced when their temperature is high, which means that when I need them, when I need to use them, when there is sun, the temperature goes up, the efficiency goes down. And this is a problem. So how to solve it? We need to find ways to reduce the temperature of these solar panels, maybe diverting the return air or the exhaust air, mainly the exhaust air from toilets or from other spaces in the building. I can just run it under the solar panels so that it will exchange heat with the solar panels and reduce the energy of these solar panels and make them more energy efficient when we are in need of them. So these approaches will help us in taking the most advantage out of these systems while implementing them.
Thank you. So we are actually expecting more integration of solar panels and to reduce the energy. So I wanted to ask Mr. Ramnani, would you like to add anything to this?
Solar definitely will be employed more and more in future, for sure. But apart from that, the whole design, concept and design aspect also needs to be looked at, as I covered in my earlier discussion as well. So making the building suitable for majority of the occupants should be the key, and not necessarily running the building at a very low temperature. This is one of the key aspect that needs to be incorporated in the design.
So we have covered insulation, solar. I wanted to also ask, how can real-time data analytics and sensors can be leveraged to optimize heating and cooling operations for large facilities?
Basically, the data that we collect from the building, and based on that, the automation system works and modulates the various equipment which are going to be cooling the spaces or heating the spaces, as the case may be. Maybe in cooler climates it will be heating the space, and in tropical climates it will be cooling the spaces. So this data collection is very important because this determines the amount of usage of the usage of the air conditioning or cooling and heating equipment. Having a smart system, having a system which responds quickly to the changes required in the building is going to be definitely helpful. And more important is giving a control to the operator to make the whole system more smarter, in the sense that at times it may not be required to run all the three if a building is having 3 chillers, maybe 1 chiller running at full load might be a better idea rather than running 3 chillers at part load, or vice versa. Same is true for the pumps, which are running, which are circulating the chilled water. Same is true for the cooling towers, which are going to be cooling those condensers of those chillers. So data collection is definitely important, and making it more smarter, adapt with the techniques which are available today to us should be the key.
Very well said. Thank you, sir. Moving on to Mr. Bengali, can you brief us about the expectations, like what future trends in thermal management technology can shape the design and operations of the public spaces?
One element which we have been noticing is that while selection of, let's say, thermal management system, be it, let's say, insulation, a lot of people are now talking about holistic solution and not looking at just element from a sake of element, which means they're talking about, let's say, in our case, what is the impact of selecting a material to the overall life of the project. That's happening. This is the right thing because every material has its own positives part of it, and it also leads to some negative as cons as well. For example, when we're talking about EPDM as a category, which we have been using in various public spaces, to me, that's the right selection of the material, considering, God forbid, if there's a fire, the smoke which is going to come out is not going to be toxic. The time available for people to move out to an exit and the path to see the exit in case of dense smoke is very difficult, and that's where people unfortunately would lose their lives, which no one wants. So that element of selection is becoming the key, and is something which is going ahead with. However, I do believe and I do request the audience to really look at selecting material also from a longevity point of view, because a lot of time, even today, selection is done with performance of product which is on day 0, which is good, but it may not perform the same over its life. So that's one request through your webinar, to share this out with the larger audience, that look at it more from a holistic way and a long-term way, because that's where we will be able to control. Otherwise, we will come out with great product, great buildings, which are great today, but may not remain great over a period of time.
Thank you, sir. That certainly long-term perspective is very important. Mr. Azmi, would you like to add anything of what future trends are we expecting in thermal management technology?
One important factor I would like to touch on when we think about controls and innovations and technologies, we need to think about how we can achieve thermal comfort for each individual in the building, for each occupant. What's happening generally is we are achieving the infrastructure being built is built to achieve thermal comfort for the bulk, for all the occupants. This is the approach. However, the better approach, or the more efficient approach, is to think about occupants as individuals. And we need to think how we implement the infrastructure, the technologies, the controls, and so on, to achieve comfort for each individual. And there are ways of doing so, but still we are in the baby steps. We are still in the beginning, and we need a paradigm shift in this regards. If you see, for example, the paradigm shift which happened in the telecommunication industry in the 90s or 80s, the phone was a black box with this dial pad, and nowadays the phone is something more different, and it achieves the caters for the personal needs of each individual. The same way we need to think about our industry. How can we have this paradigm shift to put the infrastructure and controls and so on? Because having a sophisticated control and data and collecting all of this data and sensors, while my infrastructure in terms of air conditioning and so on and lighting and so on is not that advanced, it doesn't help. I will have this data, but I will not be able to use it. So I need to collect the data and be able to have a proper infrastructure to be able to reflect the data to achieve the personal need and the comfort for each occupant. If we think in that way, then yes, we are advancing our industry. And I agree with what Vinod said in terms of why the set point should be 22 or 24. We can even do things to improve or to increase the set point, which will also help in terms of energy consumption. If we, for example, reduce the humidity, because when the humidity is high, people tend, because they only have this thermostat on the wall, so they tend to play with this thermostat to reduce the temperature set point in order to feel more comfortable, while the problem is not in the temperature, it is in the humidity, for example, and they need to control the humidity. That's why in terms of humidity, we need a separate system to deal with the humidity. So these, in terms of infrastructure, in terms of equipment, components, and so on, and how we can divide the space into zones, different zones and smaller zones. I don't want this large area to control. I need to divide it in smaller zones, even if they are open to each other, in order to make sure that people who are sitting in each zone can have, or individuals, let's say, each can have his own comfort requirements.
So we have covered most of the topics. I just wanted to ask, since it's a contemporary topic, Mr. Ramnani, are we expecting something from the budget for thermal management, thermal technologies?
There is Indian government, first of all, in 2019, they have prepared India Cooling Action Plan, which is a very detailed document. And one of the key takeaway of this document is that by 2037, they have projected the air conditioning or the cooling demands to go up at least 400%, from 2019 when this document was published, as well as, reduce the energy usage by a minimum, I think it is 30%. Both the things go hand in hand, as the aspiration of the country are increasing in terms of, having better comfort inside inside their homes or inside the spaces where people are occupying or working. Second thing is, the heat wave and the global warming which is taking place. The demands on energy, especially for a country like India, are huge. There is definitely a very, very important aspect is to control how we are going to spend this energy and how we are going to reduce this energy usage. So as far as, the government policy is concerned, it's very much in place, and things are happening as per that. So I'm sure, as the time is passing by, the more and more thrust on reduction in energy, reducing global carbon footprint is going to be coming in. And as we all know that India is a signatory to, zero carbon by 2070. So definitely this is in the long-term plan of the government of India.
Surely, we are all hoping for the best.
If I can add further to what Mr. Vinod said, it's very important for every user to understand that if I am making or building an energy efficient building, I myself will gain a lot of benefit. In terms of, let's say if I'm a developer and I'm making a building which is energy efficient, the tenants who are coming and staying across or whom I'm leasing it out would be happy because they will be spending less amount of money. I can charge more premium with respect to my rents. if I am a user, I would be able to save a lot of money in terms of making buildings more energy efficient. When you talk about initiatives from the, so that's more from an individual perspective. So while government might do a lot of initiative, I think one, if we start to think ourselves, there is a lot of commercial merit in terms of making a building energy efficient or green. Furthermore, the Bureau of Energy Efficiency also came with ECBC, Energy Conservation Building Code, which is again in the direction of guiding individuals, corporates, developers, architects, consultants to design building as per the prescriptive format or this simulation format to make it more energy efficient. So there are initiatives on the government side, but as I always believe that if I want to start making something, there's a huge commercial benefit in making any building green or energy efficient.
Thank you, sir, for adding this.